I'm going to present a mystery that scientists tried to solve for hundreds of years. They made claims and gathered evidence about rock characteristics until they finally thought they had the best explanation for what happened. This is a mystery about a city that disappeared in 19 no, not 19, sorry, in 1749. Workers were digging in the countryside of Italy and accidentally uncovered a large object, which actually turned out to be the walls of a building. So, over the next 150 years, archaeologists continued to dig at this site, uncovering an entire city. The city is in Italy in a place called Pompeii. This is the map from today's Catalyst, and you can see that Pompeii is right here, just a little bit south and east of Rome, which is the capital of the. Well, is Rome the capital? It looks like there's two stars. Someone who's more familiar with Italy should tell me which one of these is the capital. Inside the city were the remains of all the people who had lived there many, many years ago. They were found buried doing normal, everyday things such as sleeping. One man was even found pulling bread out of an oven. This is a picture that shows a dog. After the discovery, geologists and other scientists wondered what destroyed this city. To understand what happened, they put together many pieces of evidence about the rock and other geologic features in the area in order to make an argument. One piece of evidence that geologists use was the characteristics of the rock in the remains that the remains were covered with. By making careful observations, they noticed that the remains were covered in rock made of really small pieces of ash from a volcanic eruption. And here nearby, they saw this mountain, this volcano. And if you look at the picture of Mount Vesuvius, it's just right in the background of Pompeii. Pompeii is built just at the very base of the island, or not the island, sorry, of the volcano. So after studying the characteristics of the rock carefully, both in the rock formations and in the remains and around the city, geologists were able to claim that the city was destroyed by a sudden volcanic eruption. In fact, there's so much evidence recorded in the rocks that geologists were able, and I think this is really cool, they were able to confidently record events on that day in 79 AD, hour by hour. That's how confident they were. So, this is some instructions for you. Like the geologists that studied the rocks in Pompeii, today you will make careful observations of several rock samples. Practicing this skill today will help you solve the Grand Canyon mystery, which we'll work on in a later class period. You and your partner will use this student handout to record your observations of the characteristics of three types of rock. So, we have igneous and sedimentary rock and metamorphic rock. Instead of actual rock samples, each of you will receive a set of cards with photos representing four different rock samples of each of these types of rock. So you'll have one here with four different samples of igneous rock, four of sedimentary, and four of metamorphic. And I will also try to give you at least one or two rocks of each kind, but it's important to be able to see a variety of rocks. In the tables in the student handout, each of you will record the color and at least two observations about each rock. I really want to encourage you to observe the photos for texture, for different grains, and whether the rock is shiny or dull. And although you're going to be discussing this with your partner, you each should record your own observations in the table. So today as you're making observations, you're going to see smaller pieces of rock inside your rock samples. Sometimes these are sediments, but other times they are minerals. So this is a new vocabulary word. Minerals are the smaller pieces of matter from which all rock is made. There are many types of minerals, and each one has unique characteristics. So we need to understand, like, what is the difference between minerals and sediments? So I have this picture here, and it shows you that sediment grains are stuck together, but they don't fit together. And you can see that here. These are sediment grains. They stick together because they've been cemented together, but it's different than over here. Mineral grains fit together like a puzzle. And this happens because the process involving heat and pressure that form these rocks, which you've seen today in the sim. When you make your observations, be sure to notice how the sediment grains in the sedimentary rocks are different from the mineral grains in the metamorphic and igneous rock. And you know that the metamorphic rocks are formed from intense heat and pressure as things are getting pushed around and uplifted down deep in the Earth's crust. Whereas the igneous rocks are formed from magma that has melted and now has cooled. And so the rocks have a chance to have minerals that form into these different shapes. Once you and your partner are done making your observations in your table, so you should have all three of these filled in, we're going to work together as a class to complete this table. So partners will use, you and your partner are going to use your observations to describe the characteristics that all sedimentary rocks have in common. And then we're going to do that with metamorphic, and we're going to do that with igneous rocks as well. So I just want to make sure that we understand that a common characteristic are characteristics that you observed in one of the rock samples of one type. And there's so many types of rocks for each of these different types that if you tried to look at all the rocks in the whole world, you'd just be looking at rocks forever. But there are certain characteristics that you'll find that are similar in the type of rock. So for instance, this would be like an example of a discussion. So partner A will say, I observed that the mineral grains in rock 2, 3, and 4 are big enough to see. So this is for the igneous rock. So let me show you this here. So you can see that in rock 2 and 3 and 4, those minerals are big enough to see. So then you could say the only rock sample maybe in which I couldn't see mineral rocks or mineral grains is rock number 1. Therefore, I know that having visible mineral grains isn't true of all igneous rocks, so I claim that a common characteristic of igneous rocks is that they can have mineral grains that are big enough to see. And so then what you'll do is you'll do this for each of the different types of rocks. You'll do this for sedimentary rocks and metamorphic rocks. And once you and your partner have come up with a common characteristic, it doesn't have to be something that they all have, but a common characteristic that many of them have, then you're going to go to Schoology and you'll type, one of you will put your name and your partner's name, and then just copy this sentence. It just says, a common characteristic of igneous rocks, and in this case it would be that they can have mineral grains that are big enough to see. And you guys will come up with your own common characteristic, and then you'll do it again for sedimentary rocks and metamorphic rocks, and then post that for the group. After everyone has posted, then we'll take a look at all of these and we'll compile it into a table that we can put on the wall tomorrow. Okay, if you have any questions or if you want to look at more samples of rocks, come talk to me. I'll be excited to show you them. And then as soon as you've posted this, let me know so that I can give you a rock sample for the next part.